This is a two-dimensional shape in a 2D plane, and this shape has many parts. Say 1, 2, there are 2 triangles and 3 rectangles. Now, if I fold the shapes or the surfaces in a systematic way, I can get a 3D figure out of this 2D shape. So how can we get it? Let's see. You see, it can be folded. It is a 3-dimensional figure now. So what is this? This is a prism. Okay. From 2-dimensional shape, we can form a 3D shape. Now, if I reverse the process, that is, if you lay out or unfold a 3D figure, you get each and every face of the figure again. I unfold the thing, and if you see it from the top, then you can get the actual view. This is the unfolded parts. So this process, if you lay out or unfold a 3D figure, you get each and every face of the figure. And this is called the net of a solid. What is a net? A net is an outline. This is the outline of a solid that can be folded. If we fold it, we can get the solid again. It can be unfolded in many other ways also. So accordingly, a same solid may have many types of nets. Now this is a pentagonal pyramid. It has the base as a pentagon. Now we can unfold this. That means we can obtain the net of this pentagonal pyramid. Okay, this is the net of this pentagonal pyramid, and if you look at it from the top, then you will get this thing. So you can fold it like this again, and this is the unfolding of this. 1, 2, 3, 4, 5 triangles, which are the lateral faces of the pyramid. So by unfolding or in the net, what we get, 5 lateral faces of the pentagonal pyramid and the base face, which is a pentagon itself. Now let us see the net of this heptagonal prism. You can see this is the net of the heptagonal prism, and what we get 1, 2, 3, 4, 5, 6 and 7 rectangles. That is the faces of the prism, and these are the end faces, and which are the heptagon. So if we open a cube, we get these surfaces 1, 2, say this is 1, this is 2, this is number 3, this is 4, this is 5, and the base is the 6. So this way we get 6 different parts. And what is the advantage? We can get the surface area of the surfaces, and each surface are equal. So if we get the area of surface 1, we can multiply it by number 6, and we'll get the total area, total surface area of the cube. So this is what is the area. This is length into breadth. We can get the area of the first one, and that way we can calculate the a1 plus a2, etc. This is actually 6 into a1. So in actual practice, how you can draw a net of a cube? You can do it in any direction. This is shown in this direction, but you can start it in this direction also. So to start the process of drawing a net, we can start with numbering the faces. Say these are the numbers of the faces. We can start with number 1, the base of the cube. Say let us draw number 1. So this is number 1 face. Next we can do 2 and 3 at the same time. This time we'll do it in the right hand side. So number 2 and number 3, these 2 rectangles are done. Then we can do for the number 4, that is the front side of the cube, and this is number 4. Next we can do number 5, the left side of the cube, This is number 5, and the behind the cube, that is the last face of the cube. So the net diagram may be different depending on where you start and how you open the cube or how you open the solid. Then for a cylinder, we can give the number, and from number 1, we'll get a rectangular part like this. Okay, this is number 1. And number 2 and 3 are basically a circle. So we can keep the circles in both ends of the rectangle. Now for a cone, suppose we'll cut the cone along this line, and then we can unfold this part. And if we do unfold it, then we'll get a shape like this. This is not the full circle, and this quarter of the circle is missing, and this is actually 3/4 of a full circle.